Hello, we'll have a discussion on Hbase. Hbase can be thought of as the Hadoop database or the open source big table. It's a mechanism for providing random access database services on the top of Hadoop HDFS file system, or as an open source implementation of Google's big table database that happens to use HDFS for data storage. Theoretically, can be implemented on the top of any distributed file system, or indeed even a non-distributed file system. It implements real-time random access database functionality, which is essentially distinct from the base capabilities of Hadoop. Hbase tables as potentially massive tabular datasets that are implemented on disk by a variable number of HDFS files called H files. All rows in an Hbase table are identified by a unique row key. A table of non-trivial size will be split into multiple horizontal partitions called regions. Each region consists of a contiguous sorted range of key values. Read or write access to a region is controlled by a region server. Each region server normally runs on a dedicated host and is typically co-located with the Hadoop data node. There will be usually more than one region in each region server. As regions grow, they split into multiple regions based on configurable policies. Regions may also be split manually. Each Hbase installation will include a Hadoop Zookeeper service that is implemented across multiple nodes. Hbase may share this Zookeeper ensemble with the rest of the Hadoop cluster or use a dedicated service. When an Hbase client wishes to read or write to a specific key value, it will ask Zookeeper for address of the region server that controls the Hbase catalog. This catalog consists of the tables root and meta, which identify region servers that are responsible for specific key ranges. The client will then establish a connection with the region server and request to read or write the key value concerned. The Hbase master server performs a variety of housekeeping tasks. In particular, it controls the balancing of regions among region servers. If a region server is added or removed, the master will organize for its regions to be relocated to other region servers. An Hbase client consults Zookeeper to determine the location of Hbase catalog tables, which can then be interrogated to determine the location of the appropriate region server. The client will then request to read or modify a key value from the appropriate region server. The region server reads or writes to the appropriate disk files which are located on HDFS. So the entire scenario is being described in the figure shown here. The region server includes a block cache that can satisfy many reads from memory and a mem store which writes in memory before being flushed to disk. To ensure durability of the writes, each region server has a dedicated write-ahead log WAL, which journals all writes to HDFS. The region server can act as an generic HDFS client communicating with the HDFS name node to perform read and write operations to files. In the most typical production deployment scenario, each region server is located on the Hadoop name node, and as a result, a region data will be co-located with the region server, providing good data locality. This data locality will be disrupted by rebalance operations and region server failovers, but compactions which merge HDFS disk files will restore data locality. Hadoop and Hbase support a mode known as short circuit reads, in which the region server can read directly from the local disk by passing the name node. This, of course, is only possible when data is stored on data node that also hosts the region server. The three levels of data locality. In the first configuration, the region server and the data node are located on different servers, and all reads and writes have to pass across the network. In the second configuration, the region server and the data node are co-located, and all reads and writes pass through the data node, but they are satisfied by the local disk. In the third scenario, a short circuit reads are configured and the region server can read directly from the local disk. This scenario, data locality in Hbase is described in the figure shown here. The Hbase region partitioning scheme requires that regions consist of contiguous range of raw keys. This range-based partitioning has a significant impact on performance when the raw key contains form of monotonically incrementing value such as a timestamp or a incrementing counter. In this event, all write operations will be directed to a specific region and hence to a single region server. This can create a bottleneck on write throughput. Hbase offers no internal mechanism to mitigate this issue. It is up to the application designer to construct a key that is either randomized, a hash of timestamp, for instance, or is prefixed in some way with a more balanced attribute. In the Hbase time series database OpenTSDB, the timestamp is prefixed by a metric identifier variable that has a large number of values. Data for a single metric will be located in a specific region server, but data for a specific timestamp will be distributed across all region servers. As regions grow, they will be split by the region server as required. The new regions will remain controlled by the original region server, at least initially, but they are eligible for relocation during load balancing operations. The default region split policy results in regions of incrementally greater size, with the first split occurring after as little as 128 M, while the 10th region will be approximately 10 GB in size. It is possible to split regions manually or to override the split policy with custom code. One of the most important responsibility of the Hbase master node is to balance regions across region servers. The master will periodically evaluate the balance of regions across all region servers, and should it detect an imbalance, it will migrate regions to another server. This is a soft rebalance. The region's data remains in its original location on HDFS disk, but the responsibility for managing that data is moved to a different region server. Rebalancing tends to result in a loss of data locality when the region server acquires responsibility for a new region. That region will probably be located on a remote data node, at least until the next major compaction. Region replicas. Region replicas allow for redundant copies of regions to be stored on multiple region servers. Should a region server fail, these replicas can be used to service client requests. The original region server serves as the master copy of the region. Read-only replicas of the region are distributed to other region servers located in other racks if possible, which then follow the primary region server. Writes to these replicas are asynchronous to primary region server writes, so data in the replicas will not always be up to date. Hbase also supports a replication facility that can be used to stand up a duplicated Hbase database. This is typically used to duplicate an entire Hbase database in another data center. Thank you.